Hi guys, good evening. Am I audible to you all, everyone? Let me know if I'm not audible. Yes, online, guys. As Vignesh joined, Revan has. Can anybody else acknowledge that I'm audible to you all? Is my screen visible? Yes. Anyone? Let me check on the YouTube. People have joined over there or not. Yeah, yeah. Okay, so Shreya has confirmed that I'm audible. So let me go back to the paint screen. And the agenda I've shortlisted for today is data linked lists. Okay. So why was there a need to introduce linked list when we had arrays? Okay. So it's depend on the use case. It depends on the use case as to when we should use an array and when we should use a linked list. So if there is a lot of insertion, deletion operations, if the count of these operations is more, then we opt for a linked list. And if the count of retrieval information is more, just you need to fetch the data. Just you retrieve the data, then we go with arrays. So let's take a use case. So if we have a telephone contact list, and in that the names are ordered by an ascending order. Okay. And I have these names. So now I have these names stored in the array, and these are the indexes. Now, if I need to add one person in this array, okay. So now if I need to add a person, let's say any name you can say. Let's say I want to add Anthony. So if I want to add Anthony, where will Anthony go? A with A is same, L with N. So N is greater than N. So to add Anthony at one index, I have to shift all the others by one towards the right. So Ben will come over here. Chris will come over here. David will come over here. Just so to accommodate one person, we have to shift and shuffle all the rest. Okay. So if this was a array of 100, then to accommodate one record, I have to shift 99 records. So the performance is very slow when you're trying to insert or delete. Same thing for deleter. So if Ben is no more my friend, how to remove Ben from the contact list? So Ben gets deleted. Now Chris has to replace this index. David has to replace this index. Elsid has to replace this index. So whenever there is a lot of deletion and insertion, with regard, so the performance of an array will not give you the optimum result. So in such cases, we use linked lists. So how are linked lists designed to solve this problem with a minimum of overhead? There is some extra overhead. So a linked list has two portions. One portion holds the data, and the second portion holds the address of the next information. So if I have to store, so the address of this node is 1000. So if this node contains Alice, okay, so like this, I'll have all the information in the form of nodes. So let's say Alice is there, Ben is there, Chris is there, let's say assuming. Each node will have its specified address. 2000, 3000, Alice, Ben, and Chris. Okay. So the data and address of the next node, that's 2000. Data and address of the next node, that's 3000. And there are no more nodes over here, so it will be pointing to null. Okay. So here, data and address of the next node. So it points over here. Data and address of next node. So this becomes a linked list. So there is an extra overhead. You need to maintain a space for the next address at every node, which is very nominal space. And then there is one pointer which points to the head, the start of the linked list. So it's called as head. So head will point to 1000. Okay, so like this, you can form a linked list. This pointing to the 1000. Like this, it keeps. So this is very efficient when we want to add a new element or remove a new element, existing element. So as we had added, so let me add Anthony. So I know Anthony will be added between Alice and Ben. So I'll make the Anthony's node over here. So Anthony's node will come over here. So and address 4000. And it will have Anthony. Okay. And now, what do I just have to shift the pointers? This 2000, I'll put it over here. So Anthony is pointing to 2000. Means just arrange the pointers. I'm not shuffling any one. I'm just arranging the pointers. So this points over here. And here I'll make 4000. So this pointer which is pointing to 2000 will be removed from here. And I'll have this pointer pointing over here. Now I have removed an element and I have not shifted and shuffled any of the other elements. They are at their at the respective places. Okay, now if I want to delete Ben, what will I do? If I delete this Ben node, entire nodes get deleted. So now what I can do? I can directly make Anthony point to 3000. That's it. This all I'll remove, and directly I will just say that Anthony can point to 3000. Without any shifting and shuffling of other nodes, I have simply adjusted the pointers and I have made my linked list in a way that you can easily accommodate data or delete data. So if your additions and deletions are more, always advisable that you go with linked list. But fetching is more than array is the best choice. Then we have various types of linked lists, right? The linked list I showed you over here. Okay, that is called as your singly linked list. It has only a single pointer. So linked list which has only one single pointer is called as a singly linked list. Okay, so one data space, and data can be of any type. So the node of a singly linked list will be of this. This is the blueprint of a node of singly linked list. Okay, I have two areas. One, the green area for the data, and the red area for the next. Okay, so this is for the data. Data you can put up whatever type you want to. This is the address of the next page. We'll call it next. Okay, so here we have two things, data and next. Every node will have these two things, data next, data next, data next. That's it. 1000, that's 2000, that's 3000. Very clear. 2000, point me over here. Here I'll have 3000. Point me over here. And here, as there are no nodes further, I'll have a null over here. This is called as a singly linear linked list. I'll call it as a singly linear linked list. Then we have singly circular also. Same as this. I'll just copy this. Same as this. Copy paste it. But the first last node now, okay, and every linked list has a head, right? Where does the head point? Head will always point to the first node. Head will always point to the first node. That points to the first. linked list, you always have to iterate from the start. In every case, you have to iterate from the start. I'll copy this. So the last node will point to the head. Remember that. The last node will point to the head, will not point to null. The last node will have 1000. So this, it will form a cycle. This will form a cycle. It's called a singly circular. That also points to it. This is called as singly circular linked list. Okay. Then we also have a linked list, W linked list. It is called W because it has two pointers, left and right. Very widely used linked list for many data structures. Your tree is made using W linked list. So it has one data part address. So we call it as data left right. Okay. So left is the pointer. Have data in between, and then we have the right point. So if you make a linked list with this, it becomes first node, second node, have the addresses. Each has their data. The data can be any type of data. You can have strings also. It's solely up to the programmer what object is putting in the data part. I'm putting integer objects, or I can put any other object also. Then here there is no left node, so null. On the right we have right we have 2000. The left we have 1000. Right we have 3000. Left we have 2000. And right there is no node, so we call it null. It's not bidirectional. It's pointed by the top. Starting node is your head. Head points to the first. Then we have a fourth this we call as W linked list. The two pointers, so we call it as W link. And then we have one more linked list. And then the last node points to the first, and the first node points to the last. That is called as doubly circular. Okay, so in doubly circular, there are no nulls. it forms a cycle. The last node will point to the first node. First node will point to the last node. Common node, last node pointed to first node. So this will be 1000. And the first node to the last node, which is 3000. So like this, we can form a doubly linked list circular. So we call this as doubly circular. Okay, so we'll try to create as many as possible in these sessions. So let's start with the simple linked list, okay, singly linked list. So as we are using Java, so we can make a class which the data we can give of type integer because we are storing 10, 20, 30. So we can keep int data, and where it is pointing, we will point to a node. So we will call it as a node. So we'll make a node class which will have two parts, data, and where next is pointing, there is still a node. Where next is pointing, there is the node itself. So let's try to program this. Okay. Let me see if you are able to see my Eclipse screen, guys. Yeah, I'm sharing my Eclipse screen now. So I come over here. Where are we? You guys were at here, Mullah DSA sessions. Today is our day 10. Let's make a class called as node. Okay. So what will this node class do? It will have integer data and private, where it will point, there will be a node. Okay. So let's try to make a constructor. We will just pass the data. Okay. And next we will call it as null. Okay. Initialize the next as simple constructor we have written. And as it is private, we can write of getter settings. Oh. This is my simple node class. So when I will call a constructor, I will just pass the data to that, and it will give me a node with the data and the next as null. Okay. So to understand this better, what I can show you all is, it's like the metro work is going on, no? So they have made the columns, and now they need to put a big slab on the two columns. Okay. You have to put some big slab over the columns. So these slabs are not manufactured at the roadside. Okay. They are made at the factory. And from the factory, with the help of large trucks, they are shipped or transported to the site. So at the site, there is site engineer, and that site engineer will check what is the size of the slab. Then accordingly he will unload it. So if the bigger slab is there, he will unload it at a different location from the truck. The smaller slab is there, he will unload at a different position. So whenever this slab has left from the factory, the site engineer is informed that the slabs have left from the factory. Please be available at the site with the team so that they can unload these slabs and they can release the truck back to the factory. Okay, so we have a site engineer. So the site engineer will receive all the slabs from the factory. And these are all made in factory, not made at the roadside. They are made there, the factory. Order is placed to the factory. And then as per the specifications, these slabs are transported and delivered to the site engineer. Okay. So our factory will be the constructor. So whenever I would want any node, I will call the node class constructor by saying new node. And whatever data I want, I'll just pass the data. So if I say new node 10, it will send this to the factory. And what is the factory doing then? Factory is taking my data, preparing a node out of it with the data part with the data and the next part as null. So factory, what it is doing? Whatever request I say 10. So it will prepare a node for me. Okay, with whatever data I have said, it will go in the data part. And the next part will be null. And this node will be transported to me at the site. And then my site engineer. So I will call it as new node. Site engineer will call it as a new node. It should also be of type node. So whatever the constructor returns will be received by the NN. Okay. So let's try to code this now. So now once we have got, so I will go here and I will say new class singly linked list. Okay, I'll add the main. So what I'll do is I will make first I'll make the head. Okay, I'll make the head of the linked list and it is pointing to null. That is pointing to null. Now I will call the start function or create function and I will pass the head. Okay, and it will return me with the new head. So when I'm passing the head, it is null. After creation, I should get the 1000 head after creation. So let's create this. So we've got this. Okay, now visualize this to be as a train. Okay. So I brief about the factory and the site engineer. And now one more thing I need to just visualize while creating linked list. So visualize this to be a train and the head is the engine. The head is the engine. So right now there are no more coaches. So the head is pointing towards the down. So it is not being connected, it is connected to the down. Now as I ask for one coach. So one coach will come. Okay. We'll have two areas, seating area and the connecting area. So seating area, let's say, is 10. This is the address of the node. And there is nothing over here also. So this also is null. That also is null. So now what I'll do is I will call a railway employee to whom I will call. So all the oval rounded rectangles which I am making, these are just my pointers. Okay. They don't have any data. They are just mere pointers. So I'll have one more pointer called as temp. So that railway employee will do the joining job. So right now, my temp, my engine, and my first node are all at the same place. Okay. So this is my new node. So when I have only one node, my new node, my temp, and my head, they all are at the same place. So 1000 over here also. And now my engine is fixed to 1000. Okay, engine is fixed to 1000. Now if I want to add any other node, I will again order this from the factory that please send me a node with size of number 20. It will take the number, prepare the node for me after my specifications, the data as this, next as null, and will deliver that to the site. The site, it will be at address 2000. Now the NN, which is pointed to 1000, 1000 has been installed. Now the site engineer will now take care of 2000. And now using this railway guard, we can do the connection. We will do the connection. We'll connect this node over here. And after connection, the railway employee will move forward. As it connects, it will keep on continuously moving forward. So I'll come over here. Now when I ask for new node again, a new node will be generated for me with my specifications. So if I want to put 30 in it, it will put 30 in the new node. There's nothing. So null over here. Address 3000 was delivered. Who will receive it? The new node, that is the site engineer. And now this is 2000, right? It was temp as moved. So now I will put temp arrow next, temp dot next. So this is the temp dot data part, temp dot next part. In the temp dot next part, I will put NN. And should become 3000. And like this, I will keep on continue and make the link, and the railway guard will again progress ahead. So it will become 3000. Okay. This will keep on going. So I will first ask for the number of nodes I want. Okay. So if I ask for number of nodes, it gives me 3. I've got my 3 nodes completed. Whatever is my head, I will return the value of head. And my linked list has been created. Okay, so let's try to code this. So I come to the create function. I take an integer size and take a scanner variable. Scanner. Let's see here, new scanner system.in and this out. Enter size of linked list. So then take this over here then. Size equal to sc dot next. Take a for loop which will run this many times. Okay, so I equal to 1, I is equal to size I plus. This loop will go 3 times. Okay, so first I will ask for the data, which data I want. So I will say enter data for node 1. 1 is with whom? 1 is with I. Now let's say data for node 1. It will enter me the data. Maybe I'll call it as info. equals to sc dot next int. And then now I will make a order for a factory new node with the info. Okay. And who will receive it? Receive it by node nn. Okay. So now because whenever I do data structures, I have to draw them. So without drawing, it becomes very difficult to understand data structures. So I have split my screen into equal halves. Okay. Main screen is there. The paint screen towards the right and coding screen towards the left. I am sharing my entire screen. I hope you are able to see my entire screen. Okay. Now we'll draw this again. So what do we have? Okay, we have a head, and the value of head is null. Okay, that has been initialized to null, and null has been passed over here. And then we have given size as 3. Okay, so we'll make a linked list of 3 nodes. I is 1, unless they go to 3 here, enter data. So I enter 10. So what have I done? I've asked the constructor over here, right? That please give me a node with data as 10. So it has given me a node, and that node I have received at address 1000. And who has received it? The site engineer NN, and the data has been 10. And next is number. Okay, I'll just put an N over here. NL. Okay, nothing. So far I have reached. Now I will attach this head to this. So this is the only once. So I'll check if my head is equal to null. Yes, so it will be true for the first time and will be false for the remaining time. I'm writing the code. So if it is head is equal to null, is it true? Yes. Then whatever is in NN, put it into the head. And also make a new pointer called as temp. Put that NN in the temp also. Put that NN in the temp also. So now what is temp? Temp also is now NN. So now at this point of time, the railway employee, okay, this is my temp. So my railway employee is 1000, right? Head and they all are at one position. If it goes into if, will not go into else, loop finishes, I plus by I becomes 2, enter data, I enter 20, and it gets me a node for size 20. So on the factory, I get a node of 20. So the factory, all know it makes the node for the size and it passes in the next null. This was it to address 2000. Now who is pointing to 2000? The site engineer. Site engineer which was working at this site. Now this is completed. Will shift to this site. Now how do I join it? So now is my head null? No. So how will I join it? So who will help me out? And for joining, use the temp. Don't use the head. The head is stationary. Yes, anyone? Anyone from YouTube? How will I join it? So yeah, now you are able to see my both the screens. Temp dot next is NN. So where is temp pointing to? Okay, let me open up my paint screen so I can show the split screen. You are able to see my split screen, guys? Everyone? Evan, can you see the split screen? On the left side is Eclipse, on the right side is okay, yeah. Revan says, yeah, 1000 dot which part? Next part, yeah. So this part. So this part will be 2000 because okay, so I'll put over here 2K. 2K, 2000. So how will I write that? In the next part of temp, put NN. So I'll write temp dot next will be NN. Okay, but as next is a private variable, as next is a private variable, then we cannot set it like this. So how will we set it? Okay, so let's remove it the privacy as of now. Let's remove the privacy as of now. Else there will be a lot of coding complication. Okay, so let's make it public. Directly we can use that. So temp dot so temp is declared over here, so it can be only visible over here. So declare the temp outside equal to null as of now, and then put the temp over here. Then what do you do? Temp dot next equals to NN. So temp is 1000, 1000 is this 2000, goes into NN. So it joins over there. So now after joining, will it stay? Will the railway guard stay there? Or will the railway guard move ahead? The railway engineer will move ahead. So how will I put the railway engineer to 2000 now? Okay, very simple way to increment the temp is temp dot next. What is temp? 1000. What is the next of 1000? 2000 is your new temp. Okay, so the increment of temp is very simple. Temp is temp dot next. So now temp will come to 2000. So temp is coming to 2000. Temp is coming to 2000. Okay, makes sense? Yes. Else completes. I plus the I becomes 3 is still less than equal to 3. I tell the factory send me a new node with 3000. Factory sends me a new node with 30, sorry. 30. It adds null to the next part and it sends this to 3000. Who receives it at 3000? The site engineer. Okay, this much is done. Is head null? No. Then we'll go in else. What is in temp? 2000. 2000 dot next, which is this part. We'll be having NN. So what is in NN? 3000. So 3K comes over here. And so this is joined. Now the temp moves ahead to 3000. Also my loop I plus plus I becomes 4. This 4 is then equal to 3. Loop breaks. And once my loop breaks, I will return the head. Okay. Once I return the head, the new head comes over here. And then I can now display. Okay. So I'll just display the, so as it is a linear structure, everything has to happen from the start. So even when you will display, you will display the list from the start. So we'll call the display function. Okay. So here we have the display function. So what I'll do is to display, again, I'll bring the temp to the start. Again, I'll bring the temp back to the start. So I'll bring the temp back to 1000. So it will be a local variable. Okay, so it will be a local variable for this method. So we'll, and this is going to point to a node. So we'll say node temp. Okay, and by default, I will set it to head. So what is the value of temp? 1000. Okay, and then till my temp doesn't become null, I'll run an iteration while my temp is not equal to null. So now in the first iteration, 1000 is not equal to null. True. It will come inside and it will display me the data at temp dot data, and then we can concatenate some arrow to make it look like a linked list. Okay, and then you can move the temp forward. So how do we move the temp forward? We know, right? Simple way of incrementing the temp is this. And once my temp, this loop, okay, so this now temp is temp arrow next. So to temp arrow is 2000, temp becomes 2000. 2000 is not equal to null. True. So how it is going to display the data? So it will display me like this: 10 and arrow. Then temp arrow next, temp becomes 2000. 2000 is not equal to null. True. Now inside 2000 data is 20 arrow, and temp becomes 3000. 3000 is not equal to null. True. Display data 30 arrow, and now 30,000 next is null. Null not equal to null will become false. Loop will break. Now the loop breaks. I will display over here null because the single linked list ends with a null. So as I do sys out, I will display a null. Okay. So let me now run this code. I am able to see the Eclipse part now, guys. I'm sharing only Eclipse part. Yes, Devan. Yes, is my Eclipse screen visible? I'm going to run. I'm running this code from here now. Okay, now let's run it and check if everything is working fine. Okay, there's some issue. See, there's a red dot over here and there's some issue over here. So scroll till there. What happened? Okay, we have two scanners over. No, not needed, right? Not needed to scan in one class. Save, right click, run as Java application. Asking the size of linked list. I say 3. Asking me 10, 20. Okay, what happened? Null pointer exception has occurred at line number 43. Temp dot next. Just if I declare temp, will it work? It's not detecting it. So let's uh, enter data for the node I. I take a node temp. New node is the info, and head is null. I initialize the temp to null, and then it goes over here, and then goes into the head, and then go into the temp. Yes. Why is this throwing up an error? So 1 less than 5, enter data for the node. 1, I enter 10, that is scanned. In the first iteration, head is null, right? Because I have passed over your head. Initially, my head is null when I pass it. So then you put the temp into head. Oh, this is not that function over here. Initially, head is null. So size of linked list. So enter the data for the node I. Node temp. So here, if we haven't initialized it, how is it doing null pointer exception? And in the first instance, I'm initializing the n. Okay, let's put it over here. You put it here and check. That's where we have put it, right? Yes. So size 3, 10. So this iteration has worked. And now it NN has gone into temp. So NN was the address of the first node. Now for the second iteration, if I enter 20, again it's throwing an exceptional pointer. And line number 43 and line number 9. This function is being called temp.next. Yes. Whatever is in NN is going into the head. Or whatever is in NN is going into temp. So temp is being initialized with NN, no? But when it is going back, okay, so we'll initialize this outside the loop once, not every time. Else, by every loop, it will go to null. Yeah. Let's do it like this. Outside the loop, will initialize. Okay, yeah. That is what mistake we were making. You're declaring inside the loop as null, no? Okay, so in every iteration, it was becoming null. So I make 3, 10, 20, 30, and this is my linked list. So instead of doing print ln, instead of doing print ln, we can just use print. So that it is on the very same line. Okay, so now I enter size as 4, 1, 1, 2, 2, 3, 3, 4, 4. Okay, I should have used this print ln. And run. Okay, 4, 1, 2, 3, 4. And this is my linked list. I have made single linked list. Okay. Let me push this code to the GitHub, guys. So you all can try to create it. So we'll add more flavors to it as and when we progress. So mark your attendance, those who haven't marked their attendance. If you haven't marked the attendance, please try to mark it. Okay, I'll just refresh the link of the GitHub also to everyone, and you all can practice your code from there. Yes, correct. That is what we want. If you declare the temp variable outside the loop, but if you do it inside the loop, it will in every iteration we set it to null, right? That is where the null pointer exception was coming from. So let me share you all the repository. If you have not marked the attendance, please mark your attendance. I want you to add more flavors into this. So try to store, make a linked list of the data part should be the name. Okay. So if I want the data part as the name, what changes I will make over here? I'll just make this public in data to string data, right? So tomorrow we'll check if how to make other linked lists and then how to perform operational linked list, how to add at the beginning of a linked list, how to add at the end of the linked list, how to add at the middle of the linked list, how to delete from the start, delete from the middle, delete from the end. We'll try to check all these permutations and combinations. Put the code to the GitHub. So what it is that I'll take over here. I'll just make this link in the string data, right? Or I will try to check if how to take other linked list as a so keep this as a reference point, and on based on this, we'll try to create all the other linked list. Okay? It's the most important data structure among all linked list, and trees are also based on linked list. The better understanding of linked list, the more thorough you will be the understanding of your trees also. Okay, Amar sir, do you want to make any announcement?
No, sir. All good.
Okay, then we'll end for the day.
Yeah, sure, sir. Thank you. Thank you, students.